What's up guys, Fancy Creator 273 here, and today I'm going to show you some of my redstone. Well, a little bit more. So first we got a mini D-latch. This lever right here locks and unlocks the data, and you can turn it on and off. And you have this, a flip-flop version of the D-latch, so it locks and unlocks like every few ticks, which is really cool. And over here you will see a lot of stuff. So this is an SR latch. I believe I have it written down so I don't have to, yeah. So you can read that, or I can just say it. It's a set reset latch. I just call it SR latch because, well, if you always say set reset, it's gonna make all your conversations longer. So just go SR latch. It's, yeah. So that's what this is. And as you see, you press the button, goes through, and then you can reset it. And then we have this, which is a more compacted version of the SR latch. And then this is a bigger form of the data latch. The one I showed you before over there was the mini version. Let's go back to that real quick. As you see, this is the same thing as the data latch, but it's mini, and this is the flip-flop. You already understand, so I'm not going to linger on that for too long. This is just sending a signal, but having blocks block it off so they don't interfere with one another, because, you know, that would happen. This is a PC I made and then showcased last video. Oh yeah, this right here is a really interesting one. So you press this, and this is a screen display for pixels. Now, we're going to go over here. This is an XOR logic gate, which, well, XNOR. Because an XOR is the non-negated variant. This right here is an XOR. As you see, when both are on, this turns off. Rather with this, when both are off, this turns on. And when both are on, this turns on. Rather with this, when both are on, it turns off. Because this is the negated version. It's basically the reverse. Okay, so we have a NAND logic gate, which, like the AND logic gate, both have to work together, except it's a little different here because, well, these are off in order to get this signal, and then you turn them off and there's no more signal. So that's kind of cool. Over here we have a NOR logic gate, which is a negated OR logic gate. As you see, both of these have to be off, because with a regular OR logic gate, either OR can be turned on and it'll create a signal. But with this, it's all zeros. It's all zeros if one is turned on. Rather, if one is turned off, well, both are turned off, then this will turn on. So it's the reverse here. You turn one of these off, and now it's both zeros, instead of turn one of these on, and it's both ones. In the original regular OR logic gate, you turn one of these on, it turns this on. Rather with this, turn one on, it turns off. Okay, next is just some redstone clocks. This is a simple half adder. You turn this on. One, that's one. Go here, and while it doesn't make sense, that's off at first because 1 plus 1 is 2. As you see, now it's 1, 0. Which at first you might think is 10, but you see this is in binary, and binary is base 2. So what happens is 1 0 actually translates to 2 instead of being 10 like in our regular base 10. Okay, so this is the bigger full binary adder, which is pretty much the same premise, except you can actually add way more complex numbers. Okay, over here, I already showed this off, but I'm going to show you again. Decoder. It's the reverse of the encoder. So instead of basically how the encoder works is you would turn this on and it would retrieve the data from one area. In this case, you turn it on and it sends that data to this area. It's the exact reverse. For example, this is A. A over here, the light will turn off because it's retrieving the data. Because that's how it works as an encoder. This is random access memory, also known as RAM. This is the reset right here. This is the clear. As you see with this one, you can only write and clear it. And because you can only write and clear it, you can't read the data. So I made this one, which is a lot bigger. It has a read, reset, and write buttons. So you can actually read, write, and reset it, which I think is really cool. Now we got this bad boy, which I'll go into more later, but this is an AND logic gate. Both have to be on in order to get a signal. This is a NOT logic gate, where 0 is 1, 1 is 0. This is an OR logic gate, where if 1 is on, you get a positive number, a 1. Same thing. Alrighty. Sorry, I built a lot of these. So this is an SR latch, which is a set reset latch. As you see, this is how it works. You see, the problem with this, which the data latch actually fixes, is if you manage to set and reset these at the same time, both the inverted and regular output are on, which is not possible normally, since, well, normally the negative version isn't the same thing, but with this it is. So you fix that with the data latch, where you try to set or reset it at the same time, it still works. Okay. Yeah, now we're gonna go all the way over here. I know, you might have seen a lot of these used in redstone, and that's not actually because of this system where you shoot something and it creates a redstone output. Well, this is useful for some things. What we use it for is, well, as you see, redstone automatically connects to a target block. Another thing is we use comparators for many things, mainly for signals. The more items in, the more signal you get. It goes in here, and as you see, glass is one of the few blocks that redstone can actually go up like this on and still transmit signal. Okay. Sorry, I built so much. I'm trying to find something I didn't show. Did I show you this? Yeah, I did, but this is a more in-depth decoder, where, as you see, in this one, you have to put in the right code to actually get the output. Okay, this is a stacked version of the new screen, and as you see, unlike the old ones that had this sort of weird shape, it kind of reminds me of the star unit I use, but it's more like jagged and messed up. It does use 5 pixels too, so it's like a rearranged star. A rearranged version of the star. So instead of this, which doesn't look good in straight lines, it's better just to do this one, or to show you what it looks like, this. You also have this, which is a redstone clock. That's the reset. As you see, it uses a pulse generator. This is the non-piston version. Now, did I show you the pulse generators? If I don't remember. I might show you again if I already did. But first we got the RAM, CPU. This is the GPU. Yellow is adding, purple subtracting. We have the first Gen 1 and 2 screens. Pulse generators, where it cuts the signal as it goes up, so it sends a pulse. You see, how Minecraft redstone works is you have different ticks. There's a redstone tick and a regular tick. A regular tick is a 20th of a second, I'm pretty sure, and a redstone tick is a 10th of a second. So as you see here, a 1 tick repeater is regular, is how you set it down, and it waits only a 10th of a second. Here it waits 2/10ths of a second. Here it waits 3/10ths of a second, as you see. And then this is the final one, 4/10ths of a second. Okay. I know I've built so much here. Yeah, I think if I can't find anything, I guess this is the main issue with making everything in the same, like, boat as everything. Okay. Yeah, I might have shown you guys most of everything. So, now you know how it works. Obviously, RAM is random access memory. ROM, also known as like a hard drive, is read-only memory. Okay. Yeah. Might have shown you what you mostly need to see.